Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And in today we're going to talk about converting expanded formulas to condensed structural formulas. Not a problem. Let's get after it. So to convert a formula to condensed formula. Now, these formulas here are known as expanded structural formulas. They're big. All the details are there. The bonds are there. The atoms are there. Everything's there. But there's other ways to describe these things. I think most of you will agree that these things are a little hard to work at or to look at. So let's figure out an easier way. And how do you do that? Well, we're going to start basing things on group. And now, how do you group things? How I tell students to do it is imagine a dotted line between every carbon-to-carbon bond, just like this. And start breaking things into groups. If I asked you to tell me the formula for just this right here, everybody here, or everyone watching, would say CH3. Good enough, right? So this is a CH3 group. Go to the next one. If I asked you to tell me the formula for that, the molecular formula, you all would say CH2. Nothing wrong with that. Completely correct. Let's go to the next one. What's the formula for that, the molecular formula? Everyone again would say CH2. And finally, for the end, you all would say CH3. So this is and this are saying the same thing. I think everyone watching this video will agree with me that this is much easier on the eyes than that. Now, I can also make this structure a little bit more condensed. I could say, here's why I can say this. These two units are repeating in the same molecule. They're repeating one after another. So I could say this. I could say CH3, open parentheses, CH2, close parentheses. There's two of them, right? 1, 2. Put a 2 right there. CH3. So this, and this are all saying the same thing. They're all telling me the same thing. They're just different ways of looking at it, okay? So let's go to the next one. A little bit more complicated because now it's branching, but the rules apply, right? So there's my formulas. I have to make molecular formulas of these groups that are all kind of segregated from each other. So, all right, so here, CH3. Here, now here's where we have to be careful. We've got to take care of it in the correct way. There's a couple of ways to handle it. You could say CH, and then CH3. You could do that. That's not wrong. Let me just draw it a little bit bigger. So let's say now we have all of our groups are segregated. So now we're going to say CH3. And now this part here is where it gets a little tricky. There's two different ways you can handle this. Both are correct. CH for this part right here. And then you can just draw a bond, CH3. And that just, tells the reader that this CH3 is a CH3 group. It's bonded to that carbon right there. Not a problem. And then go to the next group, CH2. And the next group, CH3. This is correct. And it means the same as that. Okay, they're telling you the same thing. I think most people will agree this is much more easier on the eyes than this. Just how it goes. That's why we do these things. They make them easier to look at. All right, so let's do the different way of converting this to a condensed structural formula. Just another way of doing it. I could have said CH3, CH, CH3, CH2, CH3. So what is this doing? Instead of having the CH3 up here, like it does here, I've just tucked it into here. Let me show you another way to draw the condensed formula of this molecule that's a little different than this one. So I could have said CH3, CH, CH3, CH2, CH3. Now, what is this saying to me? What is this saying to me? This is saying that this CH, which was we did initially draw up here, saying that this CH3 is attached to this carbon right here. Now, how do I know that? Well, it can't be attached to this carbon because it already has an octet, right? This carbon is bonded to this carbon and 3 hydrogens. It can't be on this carbon because this carbon has 2 hydrogens. It's bonded to that carbon. So this carbon here has to be onto that one because there's no other way to do it, right? Because if we break the octet rule. And this CH3 must be attached to that one. And that's how this formula works. Whatever follows you in the formula is what you're attached to, okay? More or less. You'll get the hang of this one. This one's a little bit more challenging for students, but you'll get the hang of it. It's really not that difficult. All right, guys, now if you found this video helpful, please go ahead and slap that like button, leave a comment below. Tell me the kind of questions that you're working on in your organic chemistry class. Maybe I can make a video just for you. And if you could, please share my content with your friends. Let them know that this content's available. Maybe it can help them as well. And if you could, subscribe to my channel. It lets YouTube know that I'm doing a good job for you guys and that you guys are engaging with my stuff. It also gives me the encouragement to keep making more and more content for you guys on my YouTube channel. Now with that, I want to wish you all good luck and good chemistry. We'll see you all soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.